Good evening, everyone. My name is Manmohan Brahma. I'm the solutions architect leader for AMD India Mega Region. Me and my team are responsible for making custom solutions design for server space. Data center is a huge topic today, and from edge to data center and to cloud, AMD has made a significant presence. And in today's discussion, I will give a quick brief on what AMD is doing into, and I'll be very open to have any discussion, any questions if you'd like to post. Please feel free to ask me. Okay. Now, we are accelerating high performance computing. There used to be a time when people used to talk about like high performance computing means multiple systems connected together, clusters, or a kind of systems which are not affordable by the common public. 1993 is when the first supercomputer was announced, and the compute capability of 1993, you can actually you are actually carrying the compute capability on your hand. That's on a phone. Okay. Now, AMD has brought in significant innovations in terms of the process node technology, say it in the form of the CPUs, accelerators like GPUs, maybe from gaming or from high performance computing, and then we have got in Xilinx as a FPGA onto our portfolio. Now, from edge to cloud, the journey has been very significant. In today's world, you touch any equipment that has got a processor, and in most you will find you are touching a AMD processor. The ultrasound that happens, or the sonography that happens, that contains a AMD processor. The scanners contains AMD processors, and then you have got AI and analytics everywhere that is being performed. You cross a traffic signal, you get a challan at your home. Have you ever thought of it, how exactly the calculations are made, the photographs are taken, and then analysis has been performed on that particular violation, then you get a challan at your home. So that's the power of analytics, and that all happens within a fraction of a moment. Now, a photograph is taken, stored in an edge station, sent out to a cloud station for processing, and then the next course of action happens, that the challenge that you get at home. 5G, the next revolution. So the new spectrums that were auctioned few days back, 5G is the next boom, and almost all of our telecom service providers are very much geared up with their infrastructure. So we have been partnered up with all our telecom service provider to provide infrastructure background. Now, in the present 4G scenario, the bandwidth that you are seeing on your phones are close to around like 35 Mbps. In case of 5G, you will see somewhere around like 300 Mbps or more. So that's the power of the new spectrum. But how exactly the data will move? You can get a bandwidth, but unless you have an infrastructure in place, you cannot. Now, AMD brings in a significant contribution to that with the high performance storage and high performance or high speed networks and accelerators, and with the CPU put together, we get in a great level of experience, the end user experience. I know it is quite late, and learning on to or hearing on to a lot of deep technical stuff is quite boring, I will say. I know the bar is also getting ready, so kindly bear with me for 15 more minutes. Oh, okay. So please feel free to ask any question if you feel like. Yeah. So recently we have acquired a company called as Xilinx. Many of you might be knowing about it. Xilinx is one of the leading accelerator development company, and together we have got a complete portfolio of CPU, GPU, accelerators, and software together. So you come to AMD, you get a comprehensive solution with your general purpose CPUs, then you are offloading GPUs for machine learning and gaming and all. Then you get accelerators for your like packet core analysis or some sort of analysis which is not the capability of a general purpose GPU. You can actually program your FPGAs. Then to stitch all together, you get a software. Now, one thing I would like to highlight, one thing I would like to highlight over here is the software piece. We as an AMD, we are 23,000 employees globally, out of which we are 5,500 employees in India. So it's a company led by a lot of Indians and driven by a lot of Indians. So 5,500 engineers based out of Hyderabad and Bangalore developing the software stack for your CPU, GPU, and accelerators. So I would like to request everyone to put your hands together for the engineers who are contributing to this major research. The number one supercomputer is Frontier. We have brought in, so AMD is always known for innovations. We have brought the petaflop barrier. We have broken the hyperscale technologies, and then we have broken the first exaflop barrier. Now, the Frontier is the first exaflop system in the world. Collectively, there are total 500 supercomputers which are listed every 6 months. The definition of supercomputer changes every 6 months with the announcement of a list called as top 500. Now, in the top 500, Frontier leads at Department of Energy in the US, and that is powered by AMD CPUs and AMD GPUs with a specialized interconnect. Now, the power of the Frontier supercomputer, which is 1 exaflop, is higher than that of the first 7 supercomputers put together. I'd also like to highlight one more thing. The 3rd and the 10th supercomputer is also powered by AMD. So out of the top 10 in the top 500s, 3 major systems are based on AMD EPYC and AMD accelerator technologies. The green 500 is the supercomputers which are most energy efficient supercomputers. So the power per computing, whatever you are spending. So as a CIO or a CTO, you are very much concerned about when you are running your systems, how efficient they are to run your workloads. So AMD EPYC and AMD accelerators are primarily based on how much is the performance per watt that we are churning into. Now at Oak Ridge, the Frontier supercomputer, again, it leads the green 500 as well. Collectively, for the first time in the history, this system has been leading both the supercomputing list, top 500 as well as green 500 for the first time in the history. The major value proposition that we as AMD bring in are better TCO, higher performance. I will not say that many times, like when people used to say AMD hai to sasta hai. That was a word which I have heard many times. But I will not say that we are cheap, but we are reasonably priced and then lower in power. So higher performance, reasonably priced, and lower power put together a better total cost of ownership. So that brings in your solutions cost, like your licenses cost, your number of servers that you will be packing in, the power, cooling associated with. A total cost of ownership goes significantly low. Another important stuff I would like to highlight is the execution strategy. For any semiconductor industry, maintaining a consistent roadmap for 5 years without failing is something the history have never seen before. Now, 2015 is when we made a re-entry to the market, and we promised the market that we will come up with a processor which is very different. And that is the time we came up with a 32 cores processor in 2017. We promised the market to come up with another processor in 2019, and we did it. 2021, we promised again, and we came up with a 3rd generation processor. As we go and as we speak, we are gearing up for the next generation processor, and towards the end of this year, we will have the 4th generation processor, for you. Now, This is what the execution strategy, the leadership plays a crucial role over here. The execution strategy is very clear, and this brings us a great trust in the brand. So, innovation that we have brought in is from edge to data center to cloud. It is through EPIC in the form of the x86 CPU. Then AMD Instinct is a compute optimized GPU architecture for AI and machine learning kind of operations. Then we have got the Xilinx Alveo and Versal FPGA accelerators that can be repurposed for any activities like packet processing or any other specialized like compression and activities which you would like to offload it onto your accelerators. So, as I mentioned, like we have not failed from past 5 years, a leadership roadmap and a successful deployment of the roadmap. One of the big challenge which Dr. Patnaik have highlighted is we feel execution is a problem, and execution indeed is a challenge. Now, if you see over here, we have not failed in any of these. 2017 or 2015, we promised for a delivery of the first differentiated processor, and in 2017 we came up with that. The first 7 nanometer processor we promised to come up in 2019, and we did it. And we are getting ready for the 4th generation processor towards the end of this year. Yeah. One of the key things that I would like to highlight over here with the latest generation processor, we have got a great leadership in the architecture with 19% more in terms of performance per CPU core cycle. Now, to our competition, we have left them way behind. We compete with our own processors, and this comparison is made against the previous generation processor. Now, 19% in terms of architectural difference, we are bringing in 128 PCI Gen 3, PCI Gen 4 lanes. Now, that brings in a huge benefit to you. You have got more PCI Gen 4, so you are able to populate more storage onto your system. You can populate more network adapters onto your system. So, it becomes much denser compute platform. Okay. Another key and important thing I would like to highlight is the 32 MB L3 cache. Now, this brings in 256 MB of L3 cache per socket. So, this is one of the very unique feature which AMD has brought in, and because of which we are able to gain a significant amount of performance out of your applications. So, if we compare core to core, we have seen or like the top of the end bins of our competition versus the top of the end bin of AMD EPIC, we have seen something like 33% faster in terms of HPC applications like floating point operations or integer applications, and 60% in applications like TPC, database applications, you gain 60%. Now, when you get 60% application advantage on your database, you actually save 60% in terms of your database licensing cost. Oracle licensing or MS SQL licensing cost is huge. So, when you have got a faster processor wherein you are able to save 60% of your time or able to gain 60% of your performance, then you are actually able to save 60% of your total cost of ownership. Okay. Then 52% in enterprise workloads like Java and Java operations and all. I don't want to run through all the processors. So, one thing I would like to highlight over here, whether you go for an 8-core processor or a 64-core processor, across the processors we have got the same feature sets. Now, unlike our competition who have got like categorize the customers based on the name of the ornaments like silver, gold and all, we don't categorize our customers. So, for us, all our customers are same, whether you buy a $500 8-core processor or a $5,000 64-core processor, you get the same set of features. You can do the same set of, like encryption is for everyone. Security features is for everyone. Security cannot be compromised whether it is a or a 64 core server. It is the same for everyone. So that's one of the fundamental principles that we are doing and following while we design. Even in our next generation processors also we follow the same principle. One of the key myth that we heard from market is a dual socket server for redundancy. Processors don't follow redundancy principles. If you are running something and one of your processor fails, then actually you have to bring down your server. It cannot be brought up with a failed processor. And typically like we have been doing business with EPYC for the past 5+ years. We have not got any failed processor for a warranty replacement so far. So that's one of the myth which is not true. What we generally recommend is you should look at more compressed cores, like 64 core in a socket instead of like 32 core. That saves a lot of your cost in terms of your license cost for the server, the total server cost, the complexity of the making a dual socket system versus a single socket system is less. So the cost of a single socket system is less. Then the power and cooling associated with the servers with single socket is also less. Now, we have heard about data security, like data in flight, data at rest. We started creating a lot of policies around how the data should be managed when it is in cloud or when it is in on-prem data center. But has anyone thought about what about the data in use? Now, this is a major concern today. There are specialized techniques through which people can do a kernel bypass and can retrieve data. People who have got administrative access to the system can actually retrieve data which is running. Think about a situation, you go to a shopping cart and keying in your credit card details. Now, in some part of the system, it gets written in a plain English format. So, you are keying in your credit card details in a computer which gets written on a plain English. Now, a system administrator who have got access to the system can actually read your credit card details. So, that is where we have brought in many concepts in the processor itself, which you are hearing these days as confidential computing. So, confidential computing at the chip itself. So, all your data which goes on to the system gets encrypted on the fly and when it is in use. Now, how exactly this happens? So, what we have got is a secure processor within the AMD EPYC chip itself. It is not a specialized processor outside your processor, or it is not taking away your CPU cycles. It is inbuilt into the chip itself, which does not steals your CPU cycles. So, you are not you don't have a performance penalty over here. Now, this processor, every time you write any data to your memory, make sure the data gets passed through this processor and the memory and the memory device gets encrypted data. Now, in this way also, people can freeze the memories to -50°C and can try to retrieve the data within 7 minutes and so. But whatever data they will get out of these memory will be completely scrambled and encrypted. They cannot make anything out of that. So, that is the unique stuff that we have brought into the market today, and that is why if you look at there used to be a time when most of our OEMs used to have only one AMD platform and couple of our competition or blue friend partners systems. But now it is like kind of 50-50, and in CSPs like Azure you take or AWS or GCP, you have got a lot more with AMD processor based instances, because that ensures a level of next level of security for the instance. So, as GCP or as AWS or as Azure, they have got a tick mark or a bullet point to talk to their customer, stating that we are providing you a next level of security as so called as like confidential computing. So, this is what is a confidential computing implementation, or definitely it is a part of the confidential computing. Data in use is fully encrypted. Yeah. I do not want to take much time. I just want to quickly touch base upon the 250 world records, and we are counting. We have broken records in HPC, engineering, technical computing, data management, and infrastructure, and various business centric applications. Here are like a few quick comparisons. Now, one thing I would like to compare over here, like you take whether 8 core or a 64 core or a 24 core or a 16 core, core to core, you gain at least like 20 to 30% when you move with AMD EPYC. Now, when you bring in performance advantage for a 4000 core TCO story, we have just tried mapping in, like if it is a 100 server 2 socket environment on the previous generation Xeon, if you need like 100 servers with 7 rack, 45 kilowatt. If you move to the present generation one, you will get 4 racks at 36 kilowatt. But if you move to AMD EPYC, it will be just 2 racks and with 19 kilowatt of power. So, you are just moving on to 32 servers from 100 to 32. So, I would like to thank everyone for the patience to hear my talk. Thank you very much.